Hello, thank you for tuning in. This video is about eControlStudio, which is the software used to control DiamondEdge impact etching machines offered by our company. Specifically, we will talk about probably the most important topic, namely configuring the material definition, which is equivalent to calibrating your etcher to make sure that it can create the best possible etchings. The voice you're hearing is that of Andrei Larionov, Director of Economical Solutions Corporation. Our company designs, manufactures, and supports unique diamond engraving machines. Unlike laser that burns the stone, our machines physically hit it with the sharpened diamond tip. That is why we call this process Impact Etching. Our machines are purpose-built for use in monument industry and are mostly used to put portraits and images on monuments and headstones. You can find more about our machines by going on www.impactetching.com. We will cover two topics in this video. First, I'll talk about what correctly configured material definition should look like. Second, we will walk through actual procedure of setting up the material definition. I will show you step by step how it all works. Well, this might be the most annoying video of all that you watched so far because I'll be repeating same mantras again and again. Please still try to watch this video very attentively, as approach to material configuration outlined here will go a long way towards ensuring that your etchings come out perfectly. Okay, after this long introduction, let's talk about what material definition is. Material definition is obviously a separate menu in our eControl program, and it's also a separate window, but conceptually, it is best understood as composition of different parameters that altogether control how machine transfers your electronic image to the stone. Material configuration tells the machine how strong to hit the stone for each color of your image, how closely to put those hits together, and what transformation methods to use. Setting up your material definition is the key to making sure that your images look perfectly on stone. Actually, there are two components to the perfect etching. First is editing your images correctly, preparing them for etching correctly, and second is having correct material configuration. This video will concentrate mostly on material configuration, but I just kind of wanted to explain to you our grand plan in how we basically make sure that everybody can use our machines. We'll just teach you how to configure material definition correctly, and we offer you the image editing service at an extremely low rate to take away any uncertainty with that. So by having your machine configured correctly and by having us prepare your images for $20 per portrait, which is the current fee, we take away any uncertainty with using of the machine, which basically turns it into the revenue and profit producing equipment in your business, because all of the uncertainties taken away, you can predict your profits with 100% certainty, and that's what we do in terms of helping you to realize your return on investment in our equipment. When we talk about material definitions, there's one bad news and two good news. Bad news is that setting up material definition requires a little bit of work and concentration. It's not a rocket science, but I would like you to concentrate at doing this and understand how to do it. The good news are, first, that once you have configured material definition for a given type of stone, you will not have to ever change it. And second good news is that there's a rational and well-defined process of setting up the material configuration. Rational means that you are guaranteed to arrive at a perfect material setting if you follow the steps that are provided in our manual and now will be provided in this video. So, as part of the rational process, when we try to arrive at a goal, we should first define what that goal is. So let us start with that. As part of machine delivery, actually during the setup of eControlStudio, we will place this image on the desktop of your PC. This image is the so-called square pattern that we use to calibrate the your machine or to set up the material definition. This square has all 256 colors that comprise the grayscale palette. And if you look at it closely, it has those notches. Notches are signifying 16 rows and 16 columns in which those colors are adjusted. So in essence, every row represents 16 colors and every column represents 16 colors. So 16 times 16 is 256, right? The bright notches on the edges of the cube are meant to show you where those colors are, color lines are, rows and columns, when you etch it, because while you're configuring your material, you might not see all of the etched rows or columns perfectly. So the overall idea of configuring the material definition is to take this image, which contains all possible colors that will ever be present in any of your images you will be actually etching, and engrave this image on the stone. And by tuning the parameters of your material definition, you need to achieve the following 3 items. First, we need to make sure that darker, close to black colors appear as black on the stone. And those colors are 3 lower, well, approximately 3, let's just assume it's 3. Those colors are 3 lower rows in this pattern. That was item number 1 that we need to make sure we achieved. Item number 2 is we need to make sure that the whiter colors, which is approximately 3 upper rows of the same square pattern, appear as perfect black to the point where you can fill them with your finger. The assumption is that when you can fill the etching with your fingers on the stone, it is as bright as it gets. There's no need to etch any deeper, because once we damage the polish and you can fill it with your fingers, that is the color that is as white as your material is capable of supporting. Coming back to the point that this will be annoying, I will need to repeat it again because it's important, okay? So lower 3 rows of the square pattern should be more or less perfect black. Higher 3 rows of the square pattern should be more or less perfect white. That was item number 1 and number 2. And item number 3 is, in between those 2 areas, you should see smooth change of color, right? So item number 1, making sure that the lower rows are black, is to make sure that your etching has good contrast. Item number 2, making sure that whiter colors appear as white as they can be, is to make sure that your etching looks bright enough. And item number 3, making sure that there's half tones, is to make sure that your etching has that 3D effect and doesn't look like flat or overexposed. Because remember, the advantage of our technology and its distinction from more primitive technologies such as sandblasting is that impact etching is used to create portraits as well as any other images that you care to put on the stone. With portraits and with a lot of other images, it's important to have halftones because they add depth to your image. One important thing to know is that all etching heads on all different machines that we make are slightly different because it's a physical system. So the ideal configuration will be achieved at different values of brightness and contrast for different etchers. So what works on one machine might not necessarily be ideal on another machine. Therefore, really, the only criteria for correct material definition that we should use is that the test pattern on the stone, when etched on the stone with a given material definition, looks like what I've described now, just a few minutes ago. I want to show you the photograph that presents more, well, actually, I said more or less, but it's almost perfectly configured material definition, and that's what the square pattern should look like. As you can see, there's, well, 2.5 lines that appear to be perfect black, well, slightly more than 3 lines that appear to be perfect white, and you can see the half tones in between. There's like gradual increase of color saturation. So this is a good example of, this is actual photograph of pattern etched on the stone, and this is a good example of what well-configured material definition should result in. By the way, I want to remind you that whenever you etch the square on a stone, brush off the dust before analyzing it for correctness, because there will be some stone dust settled on top of the stone, which will obstruct the view of the actual etching. One more important aspect to know is once you have configured your material definition correctly, do not change it. If your etchings do not come out well or to your liking, if they're too dark or too bright, but material definition is configured correctly from the point of view of etching the square, then the problem is not your material definition, the problem is your image, the way it is prepared. And here again, our image editing service can help you, and it will guarantee that the images we give you when we edit them will look good on stone. If you prefer to do image editing yourself, those images need to be properly color balanced. They should contain all colors going from 0 to 256, and there should be a good balance of those colors. If your material definition is configured correctly, that means square looks good when etched on stone, and your etching does not come to your liking, you should not change material definition. You should make sure that your image you're trying to etch is edited correctly. Because what might happen is you might just keep changing material definitions to compensate for poorly edited image until that image looks good on the stone. But this is the process that will lead you to always modifying material definition to adjust it to the quality of your editing, and you will spend all your time doing that. It's not good in terms of time spent. It's definitely annoying. It will turn you somewhat paranoid by causing you to constantly change brightness and contrast. So nobody wins when that happens, right? For example, you are trying to etch the image that was not edited correctly and was just too dark. You jack up brightness and contrast in your material definition, and then the next image you're doing turns out to be edited well and to be perfectly color balanced, but now you have increased your brightness and contrast, and you etch that perfectly prepared image, and you end up with something that is very bright on the stone. Then you go and tweak your brightness and contrast again, and bring it completely out of whack, and nothing works because every new image will be a new set of brightness and contrast and all the other parameters. I don't want that to be happening to you. I want you to configure your material definition and not touch it as long as it's correct. And again, the correct material definition is the one where square looks like this approximately. 3 lines at the bottom black, 3 or 4 lines at the top white, and smooth change of color in between. That is the only definition of correctly calibrated material, of correctly calibrated machine. That was the first part, which I promised to be boring and annoying because I was repeating the same things again and again, but I hope that you suffered through this and learned a few very important points. In the second part of this presentation, which will be slightly less boring, we will actually configure the material definition. So what I have here, I have a material that I have created just for the purpose of this demonstration by changing brightness and contrast to some random values, which will pretty much ensure that it's not configured correctly in the beginning. I now basically emulated the situation where we need to configure this material definition. We need to adjust and calibrate our settings to make sure that we can use our machine. Before starting to etch my first square, I would like to outline the algorithm for material configuration, and if something is not clear yet, we'll come back to it and I'll show this page again. So the step number 1 is to open the square pattern. I'll call it square for simplicity. So the step number 1 is to open the square and just etch it on the stone with your baseline settings. Basically, take your material definition the way it is and do the square on the stone. Step number 2, look at that square and you need to identify heat strengths for 2 specific cases. You need to find out what was the heat strength when you just start to see the stone being barely scratched, and you need to identify the heat strength at which you see the full saturation, the white color, where you can feel it with your fingers, but not too deeply going into the stone. Basically, it should be as white as it gets, but it should not go into stone too deeply, because we're really not looking to grind the stone down. We just need to break the polish to make sure that it's as white as it gets, where you can feel it with your finger. So that was step number 2. Identify 2 points in that square etching, in that etched pattern, where it barely starts scratching the stone and where it reaches that saturation of white color. If your etching is too dark and you cannot actually identify where the whitest color occurs, increase the brightness, bump up the brightness by, say, 200, and then do another etching to identify that moment where the white color is at its brightest. Then, next step, you just adjust the brightness and contrast to make sure that full color saturation occurs at the 3rd line from the top, and that you will start to see the stone barely scratched at the 3rd line from the bottom. And the fact that it's a straight line will kind of ensure that anything in between will be smooth change in color. And that's it. If you follow this sequence of steps, and I know it's a bit confusing right now, but it will become crystal clear, I promise, after the demonstration. So if you follow the steps, you will be able to configure your material definition correctly in just 2 iterations. Basically 2 squares etched, and that's it. All right, maybe 3. Okay, so let me turn on my webcam. Okay, so we're opening the file that's located right on my desktop and called test G8 grayscale. I will make it slightly bigger than a typical test I would otherwise do. I will make it 2 by 2 inches so that it's kind of easier to see on the webcam. So let's just do all the steps. So this machine is initialized. I'll just start at the clean spot in my stone, on my stone. Slow it down a little bit for finer positioning. Okay, so start etching job. We'll start at lower left corner, and I'm pressing the run button, but let me first make sure that I'm using the correct material, which I don't. Okay, the material I wanted to, good that I checked, the material that I created for this particular test, which is completely misaligned, misconfigured, is called Demo 1. So I need to choose the corresponding material that I'm working with to Demo 1. Okay, important to make sure that you use correct material. Material configuration, material definition. Pressing Start Etching Job, pressing Run. Okay, so that was the test number 1. Let me move away the etching head and see what we can figure out from this first test. So I'm gonna maximize my all right, so as much as I can tell, and I apologize, my webcam might not be particularly bright, and for some reason it's flickering. Let us see what we can deduce from this square. Quite obvious, it's not bright enough. It never reached that highest saturation of white color. So we cannot get the moment at which the white color becomes as white as it gets. But what we can get from this particular square is the moment where it starts to scratch the stone. And well, from what I'm seeing here, it starts probably like 5 lines from the top. Okay, so that is the conclusion number 1, that this particular etching has started to barely scratch the stone at approximately 5th line from the top. What we need to do, we need to convert this 2 moments. One is when it starts to barely scratch the stone, and another one when it reaches full saturation of white color. We need to convert those 2 moments into strength of hit. Okay, so I cannot get the moment when it starts to when it reaches complete saturation, because we just never reached complete saturation on this square. So we'll need to do the second test. But as I said, we can catch the moment when it starts scratching the stone, and that is approximately, I would say, 5 lines down, 5 rows of color down from the top. Okay, now we're going to do some math. 5 rows of color down from the top. We have 256 colors in total. We have 16 colors per row, 5 rows, so we need to multiply them, and since we count from the top, we need to subtract. So 256 minus 80 colors down, that would be color approximately 176. Well, let's just say 170 for simplicity. Now, to identify the strength of hit, again, don't change that graph. This is the graph. Don't change the brightness or contrast. This is brightness and contrast that correspond to what we just etched. So don't change it yet. What we need to do, we need to move the slider down here until we reach approximately color 170. And you know which color it is if you move your mouse over here. And for the color 170, we know that the strength of hit was roughly 400. And I just noted down in the same Excel. Strength of hit for darkest gray is 400. Okay, 400. So we got one reference point from here. Now the next reference point that we need to get is to find out at what strength of hit the etching reaches its brightest color. Obviously, our material is just too dark for that. We never reached that color. So what I'm going to do, I'm going to jack up the brightness from 538 to, say, I don't know, 250 more. Okay, let's increase it to 700. Doesn't hurt. Don't increase it too much because we don't want to go too deep into the stone. But, you know, maybe I'll increase it even by 300. So, right? And I'll, just for this particular test, for the next test, I should make a smaller square. I don't think we need 2 inches, I think. Okay, 1.2 inches in each dimension will be enough. Okay, coming back to our webcam, I'll position the etching head next to our previous test. Lower the speed a little bit to position it easier. All right, and do another test. Hopefully that's the last one we need for today, and then we'll have the ideal material configuration. Okay, that was test number 2 with significantly increased brightness. It is kind of guaranteed to be wrong as well, in the sense that it will not be ideal. Sorry, I was moving the machine while I was talking, so I'll repeat. That was the test number 2. It will likely or kind of guaranteed to be wrong as well, because all I did, I just increased brightness. This test was not meant to result in perfect material configuration. The only purpose of this test was to identify the strength of hit at which the etching becomes as white as it gets and reaches complete saturation of white color. So sometimes you can get both reference points for the darkest gray color as well as for the whitest white color from running the same square. In our case, the first square was too dark, so we needed a second test to get the second reference point. As you can see, it's significantly brighter. So let's see what we can figure out from this one. I am looking at this square, and I'm actually running my fingers across it, and I can see that it reaches the complete saturation pretty much at the very top. The top line, and it's probably just a coincidence, the top line of the square is where it is kind of completely white. Maybe top two lines is where it's completely white, and the rest is kind of receding color saturation. Now, well, let's assume that we have reached the complete color saturation at the second line from the top. That would mean 16 colors down from the top color of 256. So in this case, the math will be as follows. We would reach the highest saturation at the first line from the top. That means we would have to subtract 16 from 256. That would be 240. And we would go back to our material definition. And again, this is the definition as it is now. And that is the definition that was used to etch this square. So we'll move our slider to approximately the color number 240. And we can always move the mouse to this green line to find out the exact number of color, 239, close enough. That would be the saturation, the moment at which the white color reaches the perfect saturation. And the strength of hit at that moment is, according to this chart, this graph, 723. Okay, so we found our second reference point, strength of hit for white color would be strength of hit for white color would be, as we just figured out, 723. And that's really all we need, 2 reference points to configure the material. Now, as I have explained to you before, the moment at which we should start seeing the color being just appearing in the square from the bottom, starting from the bottom of the square, is approximately third line. And the moment at which we should start seeing this color completely saturated is approximately third line from the top. So third line, you start, in this particular case, configuring material, you start from the top. So let's get the third line from the top, which will be 16 times 3, 256 minus 48. It would be the color number 208. And for that color, we should reach the strength of hit of 723. So let's do that first. So 208, color number 208, which will approximately be somewhere here. 212, 210 approximately. 209, okay, close enough. So this strength of hit right now is 676. It should be 723. Remember, 723 is the strength of hit that I have obtained from my test, where it becomes completely white. And now I'm making sure that that color is achieved, that strength of hit is achieved at approximately third line from the top. To do that, I need to increase my brightness until this value reaches 723. Right now it's 700, 15, 27, 4 down, 19, 723. Okay, we have achieved this. Now, the next goal is to make sure that we start to see the weak color appearing at third line from the bottom, which is color number 48. So again, I'm sliding my slider to color number 48. Oh, it's 47 now, it's close enough. And here I see 460 something. So it has to be 400. It has to be 400. So I'm going to increase my contrast until this value becomes 400. Right now it's 440. 420. 410. 400 approximately. The screen is unfortunately a little bit buggy, but by the time you get your next version, I'll have our developers fix it. This 350 is actually the intersect of this chart with the area of black color. I'll explain it in a minute. So now we basically have configured our material to do what we want. At the third line from the bottom, it will start barely scratching the stone, and at the third line from the top, it will reach full saturation. And I would probably be quite confident now that this particular material configuration will yield a pretty good result. There's one thing I wanted to explain first before we actually launch the etching using this material configuration is this parameter, which is called black color 0 to 20. This parameter pretty much forces our etcher to ignore any colors in the range that we specified. And we basically say that the colors between 0 and 20 are so dark that we just want them to appear black on the stone. We don't want etcher to even try to etch those colors. It will actually increase our contrast and it will speed up the etching to some degree. The good range to use for these colors, I would say anything like you can do two lines from the bottom, which is 16 times 232. So 0 to 32 is a good setting for this parameter. Okay, I'm now applying my changes, and drum roll, the final etching. If we did everything correctly, it will result in, I would say, ideal square being etched. Let's see if we can achieve that. I'll make it a bit bigger so that it's easier for us to see. Okay, let me make it again 2 by 2 inches. Oops, sorry, I need to position it first. Okay, looks good. Okay, this better work. Okay, that was the test number 3, which, if everything went to plan, is supposed to be the last one. So, as a matter of fact, I think it came out pretty well. Well, let's see where we are. So we have, I can see that it's starting to scratch the stone approximately 4th line from the bottom. It definitely reaches full saturation at approximately 3rd line from the top. which is what we wanted. And just notice how well we did from the first attempt, which was like totally wrong. In just 2 iterations, we got a square that looks almost ideal. What I would probably do, I would try to get a little bit more color here in the lower end. So I would just do probably like one final adjustment, which is kind of required in majority of cases. And I wouldn't even, in this particular case, I wouldn't even advocate doing a test. You just do that adjustment and it will definitely improve the appearance. I would just decrease the contrast to make sure that the color starts appearing a little bit sooner. Decrease the contrast by, I don't know, like 20 units. And that will do. I will not even want to run another test because I know it will fix this issue of kind of getting more color in this lower end. All right. So this is the process, and now let us try to discuss and understand what we just did. As you can probably understand by now, the entire process is based on the assumption that the heat of strength always corresponds to a certain color. As long as you don't change resolution, as long as the etching resolution stays constant during your subsequent tests, a given strength of heat will always result in the same color. So having known that, having that assumption, what we need to do, we need to identify 2 reference points. One is where it starts to barely scratch the stone, and another is where the etching reaches full saturation. By full, I mean it appears as white as it can get, while at the same time you can feel it with your fingers. It appears rough with your fingers. Shouldn't go too deep into the stone, but it should appear rough in a sense that it has broken the polish. And once you know those 2 reference points, you now manipulate this chart by changing brightness and contrast until the first strength of heat appears at approximately 3rd line from the bottom, which is 16 times 3 in terms of colors, and the second strength of heat for the widest color possible appears at the 3rd line from the top, which is 256 minus 16 times 3, right? So again, in a spirit of repetition and making sure that it all kind of becomes clearer, I want to show you all the steps again and repeat. So step number 1, you etch a square using your baseline settings. Baseline is whatever material you start with. Step number 2, from the square that you etched, likely there will be something there. So it might be too dark, but you will be able to identify the point at which it starts to scratch the stone, at which you start, not scratch, it doesn't scratch the stone, but at which you can see the color in the stone, at which it starts being slightly gray. You identify that point, and by using this chart in your material definition, you convert that color number into strength, heat strength. Also using at step number 3, using the same square, try to identify the color at which it reaches the widest color possible, and also convert it into the heat strength. If you cannot do it, and for this particular test, if it just is too dark, bump up the brightness by, I would say, 300 units, etch the square again, and then try to identify that reference point, try to identify that color number, and convert it to heat strength. Step number 4, now knowing those 2 reference points, knowing those two hit strength, you just modify your material definition to make sure that the strength of hit for the darkest gray occurs at third line from the bottom, which is approximately color number, times 3, 48, and that the heat strength for the brightest white occurs at approximately third line from the top, which is approximately color, 210, 208. And that's it. Once you follow this process, you are guaranteed to create a correct material configuration to calibrate your etcher correctly in 2, maybe 3 iterations. And once you understand the procedure and the math behind it and how it all works, it should not take you more than half an hour. So it's all pretty simple. Now let me quickly talk about the other parameters in material configuration, which we already covered in some previous videos, but still, this all belongs to the same lesson. So image resolution, which is incorrectly named here, at least in my version of software, I'll have my guys rename it to etching resolution. This is actually etching resolution. This determines how many hits per linear inch of stone surface machine creates, basically how densely those hits are put together. 127 just means that there's 127 hits with diamond tip per inch of stone surface. We do not recommend that you exceed the value of probably 150, and we do not recommend that you go below the value of probably, 80 or 90. The good setting for Jarvis dithering method is what I have here, 127, or even a bit lower, 119. For offset, you can go slightly lower. You can probably go into the range of 100. I encourage you to experiment with different resolutions, but please remember that for a given material setting, everything else being constant, if you increase resolution, you will need to recalibrate or let me put it this way, if you change resolution, increase or decrease, you will need to recalibrate your material setting by changing brightness and contrast, and again, following the same method that I explained, because when you put those hits with diamond tip closer to each other, everything becomes brighter. And when you put them more far apart from each other, everything becomes darker, right? So everything else being equal, increase in resolution usually increases the brightness of your etching, so that in order for square to look good, you need to decrease both brightness and contrast, and vice versa. Decrease in resolution usually need to be followed by increase in brightness and contrast of your material setting. Double pass is something that is used on some brittle materials like glass, where you cannot hit it strong enough because you're afraid that it will chip off. Next version of the program will actually come with ways to do multiple passes, and we had some wonderful results on less than perfect granite with doing multiple passes. I'll probably make a separate video on that. Dithering method is the way to translate the image into the array of hits. It basically determines how those hits with diamond tip are distributed across the surface of the stone. You can read about dithering methods if you can just type wiki dithering. There's a very nice article on that in Wikipedia, which kind of explains how it all works. If you do not want to get too theoretical, the rule of thumb is that we basically recommend to use offset method for perfectly black stone. If you have a good quality black stone, use offset. If you have a stone that is not a completely perfect, has some inclusions, has some sparkle, as they say, or if you have a stone which is not black at all, like red or green granite, use Jarvis. Actually, you can use Jarvis for everything. I mean, if you want to keep it simple, just use Jarvis as a default dithering method. And the rest of the like Floyd, Steinberg, etc. are just different variations of the methods that you might want to use on less ideal granite. So the idea is use offset for perfectly black granite and use the rest of the methods for less than perfect granite. And Jarvis is probably the most popular. So probably stick to Jarvis, and you can experiment with offset, I guess. I explained what black color means. It just basically tells the machine to not to etch the darkest colors, just replace them with complete black. And gamma is just changing the slope of the curve. Positive values of gamma, and I do not recommend to go above 1, maybe just stick to value of 1 if you want to use it, or even 0.5. So positive values of gamma, they create this kind of slope in this line, and in effect, it has an effect of basically increasing the contrast, because if you look at this, while keeping the brightest colors there, it kind of decreases the strength of heat for darker colors, thus making our image more contrast, right? So you can experiment with different gammas. Personally, I prefer to have gamma set at 0 or slightly positive value like 0.5. So I guess that's it. I hope I did not confuse you too much, and I hope it was helpful. If you need any help, you have any questions, please comment on this video on YouTube or Facebook, and I'll do my best to address your concerns or questions and help you understand how to configure material definition. Thank you very much for watching. All the best, and I hope you found this video useful. Thank you.